Welcome to Session 6. In this video, we will explore how to make failure useful in your Python applications. Instead of hiding errors, we will learn how to create clear evidence that helps us confirm our programs behave correctly through effective error handling, logging, and testing. Session 6 is important because reliable software doesn't mean perfect software. Systems will fail, but professional programs handle these situations transparently. The core idea is that hidden failure is the enemy. By making errors and behavior visible, we gain clarity, logs that help us diagnose issues, and tests that repeatedly prove our program's functionality. Our learning map for this session covers 4 key steps: raising meaningful errors, logging useful facts, turning rules into tests, and reading failures calmly. We will be working with the practice file day06_errors.py and the test file test_tasks.py to achieve clear, testable results without needing a browser. Let's clear up some jargon. An exception is simply a problem object created during execution. A traceback shows the path Python followed to that error. Logging provides diagnostic messages, while tests verify expected behavior. Finally, a regression is a previously working feature that breaks due to a change. A clear name for a failure is always the first step in fixing it. In step 1, we raise an error when a rule is violated. By using custom exceptions like TaskNotFoundError, we can report exactly why a function failed. This prevents the program from silently doing nothing and provides the user with an actionable message, making the code much easier to read and understand. To validate this, run your code to see the controlled error message for a missing task. The goal is to see a clear report rather than an unreadable crash. Remember, a common mistake is using a bare except pass block, which destroys evidence. Always keep errors visible to make debugging easier. Never hide evidence with a bare except clause. The bad pattern on the left silences problems, making them impossible to track. The better pattern on the right catches specific exceptions and logs them. This keeps the cause of the problem visible, preserves debugging info, and avoids masking other errors like typos or bugs. Step 2 is logging useful facts without leaking secrets. Logs help developers understand what happened during execution. We use info level for tracing normal events and the %s placeholder to safely insert values. Crucially, never log sensitive data like passwords or API keys. Run your solution to verify these logs appear as expected. Distinguish between print and logging. Use print for interface messages meant for the user. Use logging.info for developer-facing diagnostic events, logging.error for expected problems requiring attention, and logging.warning for risky situations that don't halt the program. They serve different audiences and different jobs. In step 3, we turn rules into Manual testing is easy to forget, but automated tests protect your code against future changes. By defining clear test cases, we ensure that empty tasks are rejected and that tasks can be successfully completed, confirming our program's behavior based on facts, not guesses. When using Pytest, remember 3 key ideas. Use descriptive test names that read like requirements, use pytest.raises to expect and verify failures, and use assert to compare actual results against expected behavior. Remember, a test isn't there to look clever. It's there to protect your application's behavior. For validation, run your tests with Pytest. If a test fails, examine the assertion to understand why. A common mistake is relying on real, persistent databases for testing. Always use temporary test databases or fixtures to keep your tests isolated and reproducible. Keep a passing test run as evidence of your progress. How do you read a test failure without panic? Follow this order. Look at the exception type, find the failure line in your own code, compare the actual value with the expected value, and address one assumption at a time. Run the test again to verify your fix. Our error clinic summarizes common symptoms and fixes. From handling bare exceptions by catching specific types, to checking assertion outcomes and using temporary database fixtures, these steps ensure you have the diagnostic tools you need. Remember, debugging is simply a sequence of identifying the symptom, finding the meaning, and taking a small action. For your independent exercise, break one test on purpose. Change an expected value. Run it to see it fail, and read the error report carefully before fixing it. This builds the confidence to diagnose, read, and resolve issues effectively. Understanding failure is the key to building robust, reliable software. We have reached our session checkpoint. To finalize your progress, ensure you have evidence of a passing test run and one understood deliberate failure. Document the meaning of your exceptions and why using broad except blocks is dangerous. This habit will be crucial for protecting your app, database, and future AI features. When debugging, use AI as a tutor, not a shortcut. Use a specific prompt that asks the AI to analyze tracebacks by reading from the last line upward, identifying the error type, and pinpointing the broken assumption. This helps you learn how to debug rather than simply asking for code fixes. To recap Session 6, handle misuse with named errors, log helpful diagnostics without secrets, use Pytest to protect behavior, and always check the first failure in a traceback. These habits keep your project clean and repeatable. Next, we will focus on organizing your growing application effectively.